Hey everyone, it's Justin again. In this lesson, we're going to be taking the explorations that you did in the prior lesson to solidify your understanding and go over the concepts together. Specifically, we're going to be talking about the area formulas for circles and sectors. By the end of this lesson, you will be able to use formulas to find the areas of circles and sectors. First, we'll discuss the area formula for circles. Then we'll complete one example problem. Next, we'll discuss the area formula for sectors, and then finally, we'll complete one more example problem. We'll start by discussing the area of circles. Let's briefly review some parts of circles that'll be important in this lesson. All circles have a center point, which is exactly the same distance from all of the points that make up the boundary of the circle. The segment from the center to the outside of the circle is called the radius. All radii, all the way around the circle, are congruent. The diameter of a circle is a segment that connects one point on the circle to another while also going through the center. A diameter is made up of two radii. We can't talk about circles without talking about pi. Pi is a constant that is approximately 3.14. In this course, you will be expected to use the pi button on your calculator for all of your calculations. This is going to be using the exact value for pi, instead of any rounded approximation, which will ensure that your answers are as accurate as possible. And that should be everything we need to talk about the area of circles. The formula for the area of circles is area equals pi times the radius squared, or a equals pi r squared. That means you only need one piece of information to find area, the radius. Well, that's not so bad. Let's do an example to solidify this before we move on. Here's an example problem. Find the area of a circle rounded to the nearest hundredth, given that its diameter is 14 inches. Just in case, it might be helpful to make a visual for this. Here's a circle. Now let's pop in a diameter through the center, and I'll also add in the length. Our area formula is pi r squared. Now, I need a radius to be able to find the area of this circle. Do you have any ideas about how to find the radius? If 14 inches is the diameter, then the radius would just be half of this segment. So the radius would be 7 inches. Now that I have my radius, what do you think we should do next? I can now substitute it into the area formula. From here, you absolutely can put this expression into your calculator to get your final answer. Or, if you want to do a little simplification for yourself first, you could square 7, since exponents come before multiplication in the order of operations. This would give us an area of pi times 49. This is the limit of what we can calculate by hand. If you haven't already, go ahead and put this into your calculator now. Did your calculator give you back this approximation? We have just a little bit left to do. Go ahead and round this answer to the nearest hundredth and give it the proper units label. Your final answer should be 153.94 square inches. Next, let's talk about the area of sectors. Before we can find the area of sectors, it's important to know what they are. A sector is a fractional part of a circle's area that is created by two of its radii. They might look like this, or even this. Since they are a fraction of a circle, to find their area, we're going to wind up taking a fraction of the area of the entire circle. The question is, how do we know what fraction of the whole area to take? Some sectors are a bit easier to figure out. For example, this half circle, or semicircle, would be 1/2 of the area of the whole circle. Or this quarter circle This would be 1/4 of the area of the whole circle again. But how can I tell what portion of a circle this sector is? If you think back to your circle's unit, can you think of any information that might be helpful to have in this picture? The central angle, which we represent with the variable theta. If we know how many degrees this sector takes up out of the full 360 degrees of a circle, then we can write a fraction to determine what portion of the circle it represents. When it comes to our formula for sector area, we can say that the area of a sector is theta over 360 times the area of the whole circle, which we now know is pi r squared. So here is our full formula for the area of a sector. Let's see how this looks when we put it into action. This example problem tells us to find the area of a sector with a central angle of 86 degrees and a radius of 6.8 millimeters. Round your answer to the nearest tenth. There's no picture for this problem, but we don't really need one either. If you'd like to have a visual to work from, you are welcome to pause the video here and draw your own. When finding area of any shape, it's always good to start with that shape's area formula. To find the area of a sector, what values do I need to find to substitute into this formula? I just need theta, the central angle of the sector, and r, the radius of the circle. Both of these are already given in the text of the problem. So what value do we have for theta in this problem? The central angle is 86 degrees, so theta is 86. What about the value for r, the radius? The radius is 6.8. We have everything we need here, so pause the video now and try to finish off this problem on your own. First things first, you should substitute 86 for theta and 6.8 for r. Now, this is the expression that you want to enter into your calculator. When you do, using the pi function to be as accurate as possible, your calculator should give you this answer approximation. But we're not quite done yet. We still have to round to the nearest tenth, which makes 34.7. And since the radius is measured in millimeters, our final answer is 34.7 square millimeters. By the way, did you have any trouble with your calculator earlier in the problem? If you didn't get the right answer from it, check with an adult to look at the calculator images in the answer key PDF to see what this expression looks like on each of the 3 devices that we've discussed in this course. You've learned 2 new formulas in this lesson to help you find areas of circles and sectors. To find the area of a circle, all you need is the radius. And to find the area of a sector, you're going to need the radius and the central angle of the sector to know what fraction of the circle's area you will be calculating. In addition to the practice game on these concepts, there are lots of bonus opportunities to check out in the Notes template PDF. Take a chance at challenging yourself about circles and sectors to earn some bonus gold. Good luck, and I'll see you next time!